Hi, everybody. In this video, what we're going to do is walk through the process of everything that you need to do to code in R, including vibe coding, to make sure that everybody feels comfortable and confident and has the support that they need to be able to use R and chatbot technology to be able to do these sorts of things independently. So what we're going to do here is really a step-by-step process going over key information and areas that tend to cause problems, not because of any actual particular difficulty, but just because of some little technology nuances that might not be clear if you are more of a novice coder or a novice statistical software user. So let's go ahead and talk a little bit about the data set that we're going to be using and why we have to do things the way we do to get our statistical software program to know how to handle our data set. Okay, so the first thing that I want to do is take a minute to familiarize ourselves with the data set that I've got pulled up here in Excel. So our data set is pretty darn simple in that it's just two columns, right? We have species of a variety of fleas. We've got rat fleas, we've got squirrel fleas, and if I scroll down a little bit here, we've got human fleas as well. And so these are just different flea species that have different primary hosts that they feed off of. Then in our other column, we've got plague transmissions. That's how effectively these different flea species transmit plague to human beings. And we've just got a bunch of different values there for each of these different data points reflecting a different sample from each of our flea species. Okay, so our data is organized into two different columns. We've got a categorical variable, which is the species of rat flea with three different levels, and then plague transmission, which is our continuous variable. Okay. Now, let's talk about how we have to save this to get R to be able to read it. R cannot read Excel files, R cannot read numbers files. And so that's why it's important that our data sets always be saved as a CSV. And I'm going to show you how that is in my file system as well. So what I've got here is the folder that I've set as my R directory. And you can see when you look at this file path up at the top here, I've got OneDrive, me, this is my individual laptop, and then I've got my R directory folder in my documents. Then in each one of these, and I'm going to expand this so you can see it, all of these different files that I've got that I want to be able to use as data for R are always saved as comma separated values file. Now the extension for that is CSV. So the data set that I named is class data ANOVA vibe coding. And if you were to look at the full file name, it would be class data ANOVA vibe coding.csv. Now, if you are a Mac user, this is one area that things can go wrong because for whatever reason, Macs automatically convert CSV files into numbers files. So it'll change that extension to be a numbers file instead of a CSV file. And if that happens and you're a Mac user and you try to read this file into R, you're going to run into your first problem because R will not be able to read that numbers file. Okay, so if you're a PC user, shouldn't be an issue. If you're a Mac user, you might have to go in where you've saved that file and make sure that it's still a CSV, and if not, save it again as a CSV file. Okay, so there's issue one. So the next thing that we want to do is talk about how we actually get that data into R. Right now, R does not know where that data is. We looked at it in Excel, but R has no way of talking with Excel. So somehow we have to get the information contained in this comma separated value, the CSV file, into R. So let's talk about how we do that. The first thing you have to do in R to tell it where to look for your data file is to give it instructions about where you've saved it. So let's go ahead and talk about how we do that. So first I'm just going to go ahead and hide my Zoom window here. I'm not sure if you can actually see it, but I can, and it's in the way. So I've got RStudio and what it looks like when I first open it up and I haven't done anything. So the first thing that I like to do is go in and click, sorry, I'm going to tell you what I'm doing before I do it. And I head up to this top command tab and I click on View. View gives me a whole bunch of options, but the one that I care about is panes. So I just hover my cursor over panes and then I go over here to show all panes, and that brings up this additional little dialog box where I can put my code in, but without running it so that I can make edits if I need to. Okay, so now we're ready to do the portion where I tell R where it's going to look for the data file. Right now, R has no idea where I want it to look. Now, what the phrasing we use for describing telling R where it should look is setting your working directory. There are a couple different ways to set your working directory. One is just using code, and that's typically what I use, but there's actually a much easier way of doing it, which again involves this command pane up here. So if you go up to this command pane, now you want to click on Session. And when you click Session, that's going to pull up this additional set of dialog boxes, one of which is Set Working Directory. So what you're going to do is head over to the Set Working Directory option. You're going to tell it Choose Directory. Okay. And that's just going to pull up your internal file system associated with your computer. So all we're doing at this point is saying, all right, R, this is where I've saved the file that has the data that I want to be able to access. Now, for some of you, that might just be your downloads. If you don't set up a specific R working directory file, then the place that your data will go when you download it from Carmen, where I've given it to you, will be your downloads folder. I don't like to use my downloads folder as my working directory because downloads are inherently disorganized in that they are just a scattering of literally anything that you download, whether it has anything to do with R or not. So they're pretty disorganized, but that's kind of player's choice. It's up to you. So what I'm going to do is say, okay, I know that I have my file saved first in my documents, and then, okay, I go over to my documents and I've got a folder called R directory. So I click on that R directory, make sure it's selected, and then I say open. And now, if we look down at this bottom panel here, I can see that R now knows it says set WD. Let me move that to make sure that you can see it. It says set WD, and then I can see where it's got my R directory. And if we look over here in this bottom right-hand pane, it shows all of the different files that I have. And look right here, I've got class data ANOVA vibe coding. Okay, so I know that the file that I want to read in is present in the directory that I told R to look in. So let's do a quick summary. All we've done so far, go over the file types that R can read. It cannot read a numbers file. It cannot read an Excel file. It can only read those CSV files. So we want to make sure that we've got everything saved in a CSV. We also know that we have to tell R where our data file is saved, or it will have no clue where to look. That's called setting your working directory. And we talked about how setting your working directory is as simple as going session, set working directory, and picking the place on your computer where you have saved that file. Okay, so at this point, R knows where to look, but it still doesn't know what the data is. The way that we refer to telling R what your data is and giving it that file to look for is reading in your data. Now, again, this is simple coding, but if you're not familiar with R coding, which most of us aren't, the easiest way to go about that process, and I'm just going to X out of this to make sure that my file is fully accessible. I'm going to tell it don't save because I didn't actually change anything. What we're going to do is talk about how we can use chatbots to make that system easier. Okay, so what I've got over here is just ChatGPT. Now, the actual chatbot really doesn't matter, and you are welcome to use whichever variant of a chatbot you want. There's ChatGPT, there's Gemini, there's Copilot, there's all sorts of different options, and it won't really matter terribly much which one you use as long as you prompt the chatbot with the appropriate information it needs to give you the help that you're asking for. Just like R has no idea what you want it to do until you've told it, the same is true with these chatbots. They don't know what you want. They can't guess what you want until you've told them. They also, just like R, have no clue what's in your file until you've told them what's in your file. So what we have to do when we're using chatbots to vibe code to help us figure out that coding process is that we have to be specific in the request that we give it and the information that it has to work with so it can do a better job helping us. So the task that I want the chatbot to help me with right now is to give me some code to read in my data file. But the chatbot doesn't know what my data file is. So I have to tell it. So let's start out, and I'm just going to type this in real time. I have a data file that is named, and then we're going to give it the name. Now, first critical step here. If you don't have the name right, R will not be able to read it in. You cannot change the file name at all, or R will be incapable of reading it in. So what I like to do is I go over to my working directory and then I literally just copy and paste the name there. So what I've done on my keyboard, which you can't see, is I've hit Control C, which copies this over exactly. Okay, so now I'm going to tell it exactly what it's called. Class underscore data underscore ANOVA underscore vibe underscore coding. And then I'm going to add in that CSV extension because R needs to have that. Okay. So now I have a data file that is named class data ANOVA vibe coding.csv. Now I'm going to tell the chatbot what I wanted to do with that. Write code to read this file into R. And then I just hit enter. Okay. And now it's let me know what I need to do. Now at this point, it doesn't know that I've set my working directory because I haven't told it, but we know that we already have, so we can completely ignore this. All of these things that the chatbot tells you with a number sign in front of them, that's not code. That's just the chatbot saying, hey, here's the thing that I've done for you. So for example, where we have hashtag read the CSV file, that's it telling me, here's the code I've given you to read in that CSV file. Okay, so now all I have to do is highlight the code that I want to copy. And again, I'll actually do it this way so you can see me doing it. I'm going to copy that code. So now that I've got that code to read in my CSV file, I'm going to head back over to R and I'm going to copy and paste up here into my reading frame. So let's see what happens when I hit run. Voila, it worked out really nicely. So at this point, now that I've hit that run button, R down here in my console has now used those instructions to access the data contained in my class data ANOVA vibe coding CSV file. So at this point, R has my data. Now let's talk about hiccups that we can run into here. If you do not include that .csv label, R will not be able to read it in because that's not what your file is actually named. If something has happened, and I'll just put it up here to show you an example. So let's say that you tried to download this a couple times, and now your file looks like that. A lot of times, if we download a file multiple times, what our computers will do is automatically give a number in parentheses that tells us the number of times we've downloaded it. That means that the name is now different. So if in your file system, your file name now looks like something like class data ANOVA vibe coding parentheses 1, and you use this code up here that doesn't have that parentheses 1, R will not be able to use it. So you'd have to go into your file system and rename it. Now that's really easy. So let's take a look at how we would do that. If I go into my file system and I'm just going to head over to my R directory. So let me get into that. Let's say I realize that I'm just going to use this file because I'm not using it right now. Let's say this one has that value listed after it because I've accidentally downloaded it multiple times. All I have to do is right-click that file and then click the rename button. And at that point, if I've got that, let's say parentheses 1, no problem. I just backspace it out, and now I've got the file that's named the same as what I've told R it is named. Okay, now again, critical things to check here. The file name has to be exactly the same. The file has to be a comma separated value, and it has to be located in the folder where you have told R to look. If any of those things aren't true, you're going to get an error message. So those are the first three things you need to check to make sure that R is capable of seeing the data that you want it to analyze. Now, at this point, some students ask, why can't I just copy and paste the data from the file into ChatGPT or whatever your chatbot is and tell it to do it that way? That is just an infinitely more complicated way of doing things because at that point, you can't visualize your data as effectively, and it's not ready organized into columns that R can recognize. So, the easiest way to go about this, the most straightforward way to do this, is to just give R access to the data file that you've already prepared in an organized and easily understandable manner. Okay, so now R's got the data, and we're going to head back over to that chatbot to see what other information it's given us. Now, one of the nice things that R also does is make some suggestions about things that might be useful. If they are not what you've asked R to do, you don't actually have to use them, but sometimes its suggestions are pretty helpful. So, for example, in this example, it's given you this information that this code will let you view the first few rows of your data. So let's go ahead and copy that over and head over to R here. And I'm just going to go ahead and copy and paste that in. Now, this is really a handy point to note some of the ways that R is referring to things. So you'll notice on this code that we just copied and pasted in, it has head. That's just saying it's going to tell us the headers. And then in parentheses, it's referring to data. Now, of course, we generally know that data is the information that we want to analyze, but in this case, data is actually referring to the name that you have given that file that you've told R you want to look at. So over here, when we look at the code that I've highlighted for you, that read.csv, this highlighted portion of the code is the information that says, hey, here's the data you're going to read in. But we've actually done something additional to just reading in the data file. We've also given it a name, and that's this highlighted portion here. So by saying data and then pointing this little arrow over, what we've done is say, hey, R, I'm going to call the data contained in this file the word data. So now, everywhere we want to tell R to refer back to the information contained in this folder, we just say data. So if I say, hey R, I want to know the column headers of the information contained in data, I just write head parentheses data. So now I'm going to click this run button again. And over here, what that's going to do is give me the column headers and the first 6 rows of information. So now I can see my column headers are species and plague transmission, and I see the first 6 rows of data. Pretty handy to make sure that things have been read in correctly by R. So let's go back over to the chatbot and see what else it's got. We don't need that library reader. We've already got our view data header, so that's pretty easy. So now what we want to do is think about what other information might be useful. Okay, so we already know what our column headers are, right? We've got that, and R knows that too. We also know the different values that we have for species because we talked about them already. And I want to say it was rat flea, something flea, and human flea. So obviously I've already forgotten. Now, right now, ChatGPT doesn't know any of that because it doesn't have access to the file that we have. So instead, we have to be able to tell ChatGPT what our column headers are. So what we're going to do is copy and paste from our R pane, where we're just going to highlight species and plague underscore transmission, and we're going to copy those values because we need to tell the chatbot what our column headers are. Okay, so now we're going to say, my data is organized into 2 columns, and those columns are named, and now I'm just going to copy and paste it in. So I go to paste. Okay, so now I'm going to tell it species and plague transmission. Okay, species, we're going to also tell it what type of data is contained in there. Species has 3 categories. And I'm going to go ahead and copy and paste this to make sure that I don't goof up the spelling at all. Because now I want to tell it that plague transmission is numeric. Plague transmission is numeric. Cool. Now, the next thing that I want to do is get the exact names for each of those categories contained within species. Because what I'm gonna want to do is get ChatGPT to produce the code so that I can run an ANOVA of those three categories and figure out which ones are different from one another. But first, I have to tell ChatGPT exactly what those categories are. So now what I'm going to do is ask ChatGPT to write code for me in R to get R to spit out the categories that are contained within species. Okay. So I've told ChatGPT I've got data organized in two columns, and here are the exact column names. Species is categorical, plague transmission is numeric. So now I'm going to say write code in R to provide the names of the three categories in my species column. Okay, now you notice I'm just telling ChatGPT what I want in words. I'm giving it the information it doesn't have so that it can give me the information I want. So we're going to hit enter here. Okay. So now it's telling me what I need to do to get that information. So if species is a factor, let's see if that works. We're going to just click that handy dandy little copy code button over there, go over to R, and we're going to pop it in here. So let's see if this works. Going to hit run. Didn't work. Oh dear. So let's go ahead and try a new one. Okay. Works whether species is a factor or a character, and it actually tells us that's recommended. So let's go ahead and see if that one works. Going to copy and paste that in, hit run. Oh, and voila, that one worked. So when we get a message like this from R, that's nothing to freak out about, right? It didn't work out, but no biggie. R had already provided us with an alternate option for here, and when we copied and pasted it in, it worked nicely. Now, if it hadn't worked out, and if we had returned an error code, for example, all we would have to do is let R know that. So for example, I'll give you an example of that here. So I'm going to go ahead and copy and paste this. So I'm going to copy that where it said, no, I didn't get what I wanted. And I'm going to go back over into ChatGPT and say, I got this message when I copied in the code. Oh, and look, it said, oh, you didn't do it. Oh no. So now I'm going to copy it in. That output is actually very informative. It returned null because your species column is not a factor. It's likely a character variable. So then it would say, hey, use this other thing and that'll work instead. So that works out really nicely because one, it had already told us that, but two, even if it hadn't given us that information to begin with, we solve our problem just by copying and pasting in the issue, and then ChatGPT figures out what went wrong. Okay, so now let's talk a little bit about this. So at this point, we now have the exact values that we need: rat flea, squirrel flea, and human flea. And so now we can tell the chatbot exactly what our categories are. So we can say my categories in species, I'll say in the species column are named, and then I'm just going to copy and paste in. Okay. I want to run an ANOVA on differences between these groups for, and then I'm going to use the exact variable that I want for plague transmission. So I'm just going back into R and copying and pasting that exact value or that exact name into my chatbot. Write this code in R. Okay. So all I've done at this point, again, is give the chatbot the information that it needs. My chatbot now knows what my data is called. It knows it's called data. It knows what my columns are named. It knows the categories in my species column because that's what I'm about to tell it. And it knows I want to run an ANOVA. So now I'm going to hit enter. And I'm going to tell it to stay logged out. Okay. So now it's going to give me everything that I need. Okay. So first it tells me to make sure species is a factor, and it gives me the code to do that. So I'm going to hit copy code over here, copy, and then I'm going to go over and paste it in. Now, the first thing that I'm going to do is run that code to make sure it doesn't return an error message, because if it does, I need to figure out how to fix it before I move on. Lucky me, it didn't return an error message. Okay, so now that I've ensured that first step is completed successfully, then I can move on to the next step. Now, this is another place that students often go wrong. One thing that students will do when they type in the vibe code is they skip over this first step and go right to run the one-way ANOVA because you're thinking, oh, that's what I actually want to do. But if we skip that first step, you're probably going to return an error message in R because you didn't do the first thing that's necessary and make sure that species is set as a factor. So do not skip steps. If you do, you will very likely return an error message. If you do accidentally skip a step and return an error message, that's a great place to go back and make sure you've done all of the preceding code that was necessary. Okay, so now what I'm going to do is move on to the second step that's run the one-way ANOVA. Again, I'm just going to click this handy little copy code button right here, and I'm going to go over into R and run that code. So let's go over what this is saying. This highlighted portion that I've just highlighted on your screen there, that is the actual ANOVA code. It's saying AOV, run an ANOVA on plague transmission as a product of species differences. And the data you should refer to is the data I have named data. Now, this is just naming that ANOVA. So it's saying from now on, when I ask R something about ANOVA underscore model, that will be referring to this ANOVA that we've run. Okay, so I'm going to hit the run button. Cool. Now I see that that ANOVA ran successfully, but I still have no clue what the results of that ANOVA are. That's what this next command gives me. Summary says I'm going to give you the information contained in that ANOVA model that you just ran. So now I'm going to click run again, excuse me, and that's going to give me my ANOVA output that I've highlighted down here for you. So let's take a look at that. When I look at my ANOVA model, I've got species as my factor of interest, and then a whole bunch of things over here. We've got degrees of freedom, the sum of squares, the mean sum of mean squares, we've got the F statistic, and we've got our p-value. This is the bit that we really care about over here. That's our p-value. And you'll see that our p-value is 8.28 times 10 to the negative 8th power. That is super duper duper significant, way less than a p of 0.05. So now we know, okay, we do have significant differences between at least some of our groups. But at this point, since we've only run an ANOVA, we don't know which groups are significantly different from one another. So now we have to tell R that we want to do a Tukey's post hoc analysis. And like everything, there's no sense in us figuring out how to do that code when we can just use ChatGPT for it. Now, lucky for us, ChatGPT already knows that the next step, if your ANOVA is significant, is to run a Tukey's post hoc Tukey's post hoc test. So if you look at what ChatGPT has already given you, we already have the code to do that. So now all we have to do is copy and paste this code. And it even tells you in ChatGPT, if the ANOVA is significant, run Tukey's post hoc to see which groups differ. So I'm going to copy that code, and again, I'm going to head over into R. Okay, so I've copied and pasted it in. Now I'm going to hit run differences, or hit run model, excuse me. And at this point, now I've run my Tukey's post hoc. Over here in my output, I've got all of the comparisons. So rat flea versus human flea, squirrel flea versus human flea, squirrel flea versus rat flea. And what I've got here is the differences between those groups in my first column, and then over here, my p-value that tells me how significant those differences are. What we can see here is that rat fleas are super duper different in their transmission rate to humans than human fleas with a p-value of 0.000, a bunch of zeros, 4. When I look at squirrel fleas versus human fleas, my p-value is really big, 0.91, etc. Not significant at all. When I compare squirrel fleas with rat fleas, again, I have this super significant difference with a whole bunch of zeros after that decimal, 1, 1. Okay, so at this point, I know which groups are different from each other, but I still don't have means for my groups, I still don't have standard errors for my groups, and I still haven't visualized my groups in the form of a bar graph. So now let's think about how we can use our chatbot to do those things. Now, the nice thing is that we've actually already got that in the chatbot suggested code. It says optional check group means. So let's go ahead and see what happens when I do check those group means. So I'm going to put that up in my upper left coding window, and then I'm going to hit run. And look at that. The code worked first time through, and now I have the mean plague transmission values for each of my different flea species. Okay, so we're doing really well. But generally, when we make bar graphs and we're plotting out group means, we don't want to just do the means. We also want the standard errors. And right now, all we've got is our group means and no standard errors. So again, let's go ahead and use our chatbot to say that that's what we want to do. Now, over here, the chatbot has suggested that we can check ANOVA assumptions. That is a very useful tool statistically, but we're not going to worry about you checking out model assumptions. That is something that would be very appropriate in a statistics class, and it would also be something that you would need to do if you were planning on publishing this or something like that. But for our purposes, we're just trying to work on basic statistics literacy. Okay, so we're going to ignore this suggestion from from ChatGPT for now, not because it's a bad one, but because it's beyond the scope of our needs. Okay, so now we're going to tell it that we want to generate code to produce standard errors for our group. I want to generate code in R that produces standard error values for each of my groups within species. Now, at this point, I'm probably okay referring to those groups within species as just groups rather than providing the specific group names because I've already told the chatbot what my groups are named. That means the chatbot already has that information, so I don't have to reiterate it. Okay, so let's go ahead and hit enter. Okay, easy. To compute the standard error of plague transmission for each species group in R, use this code. Okay, now this one says cleaner version with mean, standard error, sample size, and standard error together. Sounds good. This one says base R solution, which would just give me those standard errors. So let's take a look at what each one of those does so that we can get used to interpreting potential different paths that ChatGPT might send us on. So we're just going to copy over this first base R solution. So we'll go over here and see what that looks like. Okay, so now I'm going to run that and see what that output looks like. Pretty straightforward. When I hit that code, it gives me those standard errors. Now, one thing that you'll want to notice here, when we look at these outputs, the top output was our means. This bottom output is our standard errors. If you were only looking at this output, you wouldn't be able to tell that just from that data set. So it's really important that you keep in mind the code that you're giving R and therefore what output it's giving you. Now, that's not hard if you're going step by step. It would be confusing if you just tried to copy and paste everything in at once and just spam the run button and not really have any clue what's happening as you go. So this is why I recommend that stepwise process. Okay. So now let's take a look at the next option that R gave us, cleaner version with mean, standard deviation, N, sample size, and standard error together. So let's just hit copy code again on that, pop it on over into my R coding pane, and we're yet again just going to hit run. Now this one is quite nice because it does give us all of that information. Now you'll notice the way that this code output is that it's got plague transmission dot mean. So I know everything in that column is means. This has plague transmission dot standard dot SD. So I know that's standard deviation. Same thing with N, sample size, telling me my sample size is 10, and standard error showing me that my standard errors are in this column. So now we're really cooking, right? We've got most of the things we need. So now what we want to do is visualize that data. Okay, actually, let's take a look at what it says. Tidyverse, if you're using it, we haven't talked about installing that yet, but that would also be fine. Okay, we don't have to worry about that just yet. Because now what we want to do is say, all right, I want to visualize my data in a bar graph. Just like everything before, what we have to assume is that the chatbot doesn't know what we want to do, and R doesn't know what we want to do. So we have to tell it that. So I'm going to say, I want to produce a bar graph in R showing means and standard errors of each of the groups in my species column for, that's not what I want, plague transmission, and I'll just go ahead and copy and paste that from up here for plague transmission. Okay, let's see what happens when I hit enter. Okay, here's a clean publication quality code using ggplot2 to create a bar graph with means plus standard errors. Now, you'll notice at this point, R has told me, hey, in order to do this, or not, excuse me, ChatGPT has told me, in order to do this code that I've just given you, you're going to need to have these libraries, these packages installed in ChatGPT. Now, handy, it gives me that code. So let's go ahead and hit copy code. And then I'm going to go over and paste it in my code window up here. Okay, now at this point, like I've told you, we want to run the code step by step to make sure that we don't return errors and that if we do, we can solve those errors as we go. So first, I'm going to make sure that I can load this Dippler package. Run. Cool, worked fine. No problems at all, it worked. Now I'm going to make sure I can run this ggplot2 package. Hit run. R thinks about it. No errors returned. We're golden. Now, we've actually already done this next step of making sure that species is a factor, but ChatGPT has given you that code again just to make super sure. So I'm just going to hit run again to make sure nothing goes wrong. And lucky me, it did not. Okay, so far we're doing good. Now we're going to do this create a summary table. Okay, so this is just giving that information that's required for R to be able to create a figure. So now we've gotten down to this code part that says create bar plot with standard error bars. Let's click it and see what happens. Okay, and it worked out really nicely. Okay, so at this point, I've got a figure of mean plague transmission by species that demonstrates the averages for each of those groups with standard errors. Now, right off the bat, this looks pretty good. Now, I do also have a warning message here. Warning, using size aesthetic for lines was deprecated in ggplot2. Please use line width instead. So if we get that warning message, to be totally honest, we don't terribly care about it in that we've already got the graph that we want, but just for the sake of investigation, let's pop that into ChatGPT and see what it says. This warning is just telling you that size is deprecated for lines in newer versions of ggplot2. In your code, it comes from this line. Fix. Here's the updated plotting code. Oh, okay, so let's copy in that updated plotting code that says it fixes that warning message that got returned. So I've just copied and pasted that in, and now I'm going to hit run. And voila, I've got a new plot code with functionally the exact same information, but absolutely no error messages returned. And I didn't have to do anything because ChatGPT already did that for me. Now, this is where we can really start to kind of have fun with building out these figures with a chatbot because honestly, this figure's kind of ugly, right? So let's say I want to change things up. Maybe I want my bars plotted in descending order. So I want rat flea first, followed by squirrel flea, followed by human flea. Okay, so let's go ahead and tell the chatbot that I want to do that. I want the bar graph, bars in my graph to be organized in the following order. Okay, so now I'm just going to scroll up to find where I told it what my groups were so that I can copy and paste those exactly. Let's see, I have to go up a little bit further. I've already told it my groups. So here we go. Rat flea, squirrel flea, human flea. Okay, so I'm going to copy and paste those and go down here. And I'm going to remind myself by looking in R which order I want. So I want rat flea, squirrel flea, human flea. No, yeah, I do want that. I want rat flea, squirrel flea, human flea. Okay. Oh, perfect. In the following order. So it actually worked out nicely. And then I'm going to tell it update the code for the graph. Okay. So to force the bars to appear in this exact order, you need to manually set the factor levels. Okay, so I'm going to go ahead and copy this code that it's given me. So I just hit that copy button up top, and now I'm going to go over here, and I'm going to stick it in my coding window up top. I've already installed these packages. It does not hurt to, or not installed, excuse me, to load those packages again. Literally doesn't matter. So you can hit run again just to be sure. And now I'm going to tell it the order I want. And now I'm going to create that table that R is using to make the graph. And then I'm going to get down here to the final plot window. And voila, it's reset it according to my specifications. So hopefully, what this has done is given us some key insights into the way that we go about using that pair of a chatbot with R and the information we have to give both of them. What you're going to do this week for homework is again practice these sorts of processes independently to make sure that we're all on the same page so that when the time comes, you can independently use these without the headaches and hassle and with independence. Okay, so that's all I've got for the guided portion of this. I have this data file in the Carmen window or in the Carmen module, in addition to an extra file for you to get that practice without being able to do a literal one-to-one with me walking through it yourselves. So, that's all I've got for now. As always, if you have any questions, you are more than welcome to chat with me in office hours. No appointment ever needed, and I am happy to help. All right, everybody, have a good day.